Hi, welcome. So Colin Platt, I'm product lead for Makina. Very quickly about Makina. So we are a DeFi execution engine. We build institutionally focused DeFi vaults, helping bring larger institutions on chain. Our core insight really when we started building Makina was around how these current vault ecosystems were not really built with the minds of institutions. We're seeing kind of a move from investors going from more of a retail scale to larger high net worth individuals, even beyond that. And we wanted to enable tools that could automate those workflows, bring more risk controls, bring cross-chain risk controls, and help people better invest. One of these ideas that made it possible, and what I'm going to talk to you about today, is Weiroll. So Weiroll is a really unique composability engine that brings a scripting VM on-chain. And if my slides work here, that'd be even better. So, when we talk about DeFi, when we heard about DeFi in the early days, it was all about composability. We heard about DeFi Legos a whole lot. While very cool and kind of the superpower of DeFi, it does present a few challenges, especially when we bring this into smart contracts, when we bring this into vaults. We really have two options on the table. Currently, with the existing infrastructure, we can either have custom smart contracts, so adapters, if you're familiar with how Yearn works, Veda, or other technologies, or we can have multiple separate transactions. So this is going through, doing one after another, executing each one. Of course, if we go with the first option, that requires us to build new smart contracts every time we want to integrate anything. Potentially, we need to go through a whole new audit cycle. This can cost a lot of money, take a lot of time. That opportunity may be gone by the time you're up and ready to run. The second is if we use the existing tools and do things sequentially, well, we face more gas costs, race conditions potentially, and no atomicity. This is really problematic, especially when we're trying to unwind things. If we're going into looped contracts, if we're trying to pull out of looped contracts, it may just take a lot more time. If we're in a hurry, if we're worried about getting out of something ahead of an attack, this could cost a lot of money over time. So if we take kind of a simple example here, and we want to work across protocols. Say swap ETH, USDC, deposit that in a Pendle, take your PT, use that on Morpho. Right now, that requires several different interactions. With Weiroll, we can potentially bring that all into one by providing the scripting language. So, everything's showing correctly? Perfect. This scripting language, what is it? What does it come from? What does it deliver exactly? So, kind of in short, you can think of it as a lightweight on-chain VM. What we mean there is it's a virtual machine that allows us to put in different calls that can be chained together, that can speak to each other within a single transaction, passing inputs from one side to the other. This is a little bit different than if you've heard of multi-call, which is something you may have actually used without realizing you're using it, where you have independent calls that need to be pre-programmed in. The power of Weiroll and being able to bring that together in these dependent chains of commands is really allowing you to pass that information across and lock down and retain what exactly you're doing within that transaction. So if you kind of think of this in this chain of commands we have on the right side here, we have this light chain VM that we target. We pass an arbitrary call to contract 1, which passes information to contract 2, contract 3, so on and so forth. I won't jump into it exactly right now, but you can wrap these in permissions, and having this all together in a single call rather than a multi-call structure gives you the power to really have those controls that we'll talk about. So, Weiroll, a little bit more in depth here. Where did it come from? It's been around for about 5 years. It's an open source project. It was started by Nick Johnson of VNS, as well as Dean Eigenman, who was a co-founder of Dialectic, who was one of our design partners, as well as a number of other contributors. It's essentially two different parts. The first takes in commands and allows us to structure information around the commands, and the second is an array of state. The VM itself is stateless. The commands that we pass in can hold that state. It allows us to execute sequentially within inside of a transaction. It doesn't have direct support for fors and loops and that kind of stuff, or if statements. Those can be added on through kind of external helper contracts, but they're not core to the VM itself. It's a sequential execution or a revert. It allows us to do quite in-depth things. We can have up to 127 elements. We can pass in arbitrary byte length information dealing with a state next to that. Why is this important, and where does this kind of take us? When we look into how we can pass this information, it's, as I said, a kind of simplified lightweight VM, allowing us to deal with really anything on-chain. So conforming to anything that has an EVM execution layer command that we can deal with. Obviously, anything off-chain is outside of the scope of what we're talking about. We're allowed to pick the selectors against a target contract and pass in flags, as well as input dealing with that state, defining where it comes in. Because we can deal with anything on-chain, it means we can integrate anything on-chain. This is not just a specific thing that we're looking at. This is something that any project can really integrate as a way of dealing with its on-chain transactions. So we think this is extremely powerful, and we think this will bring a lot more control, potentially can prevent things like what we saw with Bybit on the back of safes, where UIs were getting compromised, because you can lock this thing down and you can define exactly what happens and pass that information through in a very controlled manner, adding whitelists, adding blacklists to those transactions, and controlling it exactly where it needs to go, and only the information and only the types of information that you want to be free and available. Going into this, we also have a lot of control about exactly how we pass it through. We can add more information about whether we're passing a delegate call in, whether we're passing a normal call, or just reading information through static calls. Because we can chain them together, potentially you need to read complex static calls to pass in to your delegate calls. You need to pass through value. If we're dealing with something like wrapping, unwrapping ETH, we may need to do that mid-chain. This information can also hold a lot of information that we saw earlier about flags that I was kind of alluding to. So the original version of Weiroll just had this toop, which allowed us to also execute without decoding it through the machine, an extension to kind of give us more information around what we can do, as well as these call types. That wasn't full and complete, so we do need to talk about how that's extended. But first, I want to kind of jump into the execution pipeline. Of course, we're dealing with something that is a VM. You do need to do a little bit more work and coordination before. There are packages in Rust and JS if you're interested in doing that. We can put this together. In our term, is done through instructions, which kind of does that VM level interaction and then passes that through. When we actually go to hit on-chain, we're decoding this on-chain. We're encoding the inputs into the machine, and we're doing each one of these individual calls. The output is decoded, returned back into the subsequent call. And this is really kind of that power when I was talking about how we chain things together and we have this dependence. Things can be pre-computed, but things can change before our simulation and our execution on chain. And if we want to leave a long-running command out there and we want to just execute, let's say, when things fall into range, we may not beat that race condition, and we'd want to revert if we're trying to do a swap within a different limit order. This gives us the power to kind of do that, revert backwards without killing the rest of the chain. It allows us to do that on chain. I don't know if anybody went to any of these MEV on all, let's say L2s and other private chains. This gives us the ability to kind of reduce that gas usage because we don't need to constantly query and run everything to check it. We could do this more elegantly through something like a Weiroll. We also have, as I mentioned, we also have a lot more availability. I am sorry that somebody is calling me in the middle of my presentation, and it keeps buzzing. We need to extend this because when we talk about the practicalities of DeFi, we talk about a lot more than just calling an individual contract with a selector and some inputs. Those inputs may be arbitrarily complex. So if we look at something like Uniswap or Curve that can take in arrays or different types of toops that need different information, Enzo kind of did another iteration on top of this, adding information that allows us to define dynamic inputs, tuples, as well as arrays. And this allows us to deal with virtually any contract out there, just through these additional flags on top of that. And that's something that really made what we're going to talk about with Makina possible. We deal with arbitrarily difficult contracts, arbitrarily difficult interactions with DeFi, or it can be used outside of DeFi, of course, and bringing that control, as I said, on a long-running basis, defining what we do and do not want to be able to customize. Like we may have an instance where we can pass in commands for a set list of stablecoins that can be swapped against ETH, but not other stablecoins, and that could be defined through a single instruction. So, very quickly, how do we use this? How do we put this into practice? As I said, kind of coming back to it, it's a cross-chain asset management protocol. We can deal with anything EVM, using liquidity bridges. We plug in with Wormhole CCQ to kind of send information on what can and can't be verified across chains through L2 ecosystems. And we solve essentially a problem that exists in the Vault infrastructure, which is how do you get away from rigid inputs? Things change over time. We need different strategies over time. We need to be able to control and not move from one free state to another free state. We need to make sure that it goes through a process. But we also don't want to force users to migrate every time they want to do something new. This is a lot of headaches for users to say, I want to invest into this thing. Now this thing no longer brings the value it did. I want to move someplace else. It's easier to pass something that has a little bit of flexibility within a controlled infrastructure, as well as potentially moving across chains where new opportunities may exist. So we leverage Weiroll specifically to get there. We don't have custom adapters, as I said, because we can use Weiroll as our interaction interface. And we control what can and can't be done through a separation of church and state effectively, what we call operators, which is our term for strategists or curators, a risk management control that says what is and is not out of, in scope, through a simple Merkle infrastructure that checks an individual instruction that's being sent to Weiroll before it's executed, allows us to read, is this allowable, and then passes those inputs into the Weiroll VM deployed on each chain that we work with, executes that transaction, and brings the value, those positions, back into the vault itself. Because we have that power to be able to do these things, we can onboard and we can integrate much more quickly in a controlled manner. We can ensure that we're not passing around information or potentially positions and transactions are held in an adapter contract that opens new services. Again, as I said, needs to be audited, needs to be checked at each time. We're firing through the same VM. We can simulate those outputs. We can see how those outputs will interact with the chain itself and bring that position back in a secure manner that adheres to what institutional investors expect based on what they get from TradFi. As I said, we have a little bit different architecture. If I were to kind of show you this image that's in front of us, machine, our term for vaults, we'll have lots of different adapters based on what you need to deal with. So if we go back to our original thing, talking to Uniswap, talking to Pendle, talking to Morpho would require 3 different interactions. This allows us to just target that lightweight VM on chain, pass those instructions in, and talk to protocol 1, 2, and 3. The other power is, because we can define this on mainnet, we can also carry that through CCQ into L2s and say, we want exactly this. That means that as soon as money is bridged over from our vault on L1s into an L2, we can enforce that same level of risk and control without needing to rebuild the entire infrastructure, without needing to rebuild all of those adapters and plugging into those. We simply put in the protocols live here, the assets live here, follow the rules in how we do it elsewhere. It's extremely powerful and extremely lightweight. Beyond EVM, hopefully this shows, there's also some really cool things. I'm going to show you a quick demo here today. We effectively use Hyperliquid EVM, if those of you that aren't familiar with it. Hyperliquid has kind of 2 chains in one, an EVM setup as well as their core, which is if you've dealt with the perps protocol. They have some cool custom pre-compiles that allow you to use the EVM layer with their core layer. And what I'm going to show you today is just kind of a quick demo here of us using that precompile in our controlled structure to execute perp transactions directly on core. So if this plays, here we go. We can see on the left here, this is us passing information to the VM on Hyperliquid EVM. On the right side, this is a screen looking at core. This was taken about 10 days ago, so the prices are a bit higher than where they are now. We're going to go in, we're going to open a position with Bitcoin USD on core through the EVM layer against a Weiroll instance. Takes a second. We'll be able to see in just a second those orders come across, entering information about what we want to trade, different information. That's passed in through a normal call data. We're on the EVM layer here, reminder. Information's put in. We can see the order open here on the right. So we've actually opened an order here directly on Hyperliquid Core from the EVM. We can control this in the same structure from the EVM. This allows us to potentially do things for the first time that EVM layer non-custodial vaults have been able to do. We can do this directly where a user deposits from mainnet, carry it across to Hyperliquid EVM through a bridge, transact, do hedging, transact, do perp spaces trading, all kinds of things that open up new possibilities to get new alpha and bring that back to the users without them needing to move across chain, without them needing to trust somebody else's deployments, without needing to trust that the bridge on the other side receives it and does only what they've been instructed to do. We think this is extremely powerful in our implementation. We also think there's a lot of power for Weiroll well beyond this. highly recommend people to check out some of these resources that I'll share in just a second, and talk to you a bit more about what's been done if you have time after this. But just kind of recap, Weiroll, gas efficient, lightweight, scripting VM on EVM anywhere you want it. Enzo Weiroll bringing that into DeFi reality. Makina, we bring that together with vaults. If anybody's looking at setting up vaults, operating vaults, would love to chat with you that as well. If you'd just like to learn a lot more about what's going on in the background, or if you'd like to get in touch with me or find out more about Makina, all the information's here. Highly recommend the resources we have. And thank you very much.